Hello and welcome to this tutorial. In this tutorial we will learn how we can simulate a circuit in a PSPICE using the classical coding based technique. So in order to do so, let's have an example here. We are going to simulate a circuit in which we will find the unknown voltage and the current for this very simple circuit. So we have voltage source, one resistance here, and another path connected here. I think this circuit is enough to understand the basic concept. We have the three steps. First of all, we will make this circuit ready for the PSPICE. By ready, I mean that we have to define the nodes that will define where our elements are connected. The second one is to find the unknown currents in this circuit. We will insert a dummy voltage source here with a value of 0 volt. So this means that it will be a short circuit path. However, this software, the PSPICE, actually requires to have a dummy voltage source connected in series with the path where we want to find the current. So when we redraw this circuit, first of all, let us define. We need to know about the voltage, and this is the resistance R1, this is R2, and this is R3, and this is the V1. So we want to know the current I1, we want to know the current I2, we want to know the current I3. So when we will make this circuit ready for the PSPICE, then we have to define a few things. So we will modify this circuit like this. This is our same voltage source V1. Since we need to know about the current I1, which is this current flowing through this path, I2 is the current flowing through this path, and I3 is the current flowing through this path, R3. So we need to have a dummy voltage source connected here. We will call it Vx, and this is R1. Here we will be having another dummy voltage source because it is stated that we need to measure the current I2 here as well. So we are going to add an additional resistance here. We are going to connect it here, and then we have another dummy voltage source here. This is the same resistance R3. This is R2, and this is R3. This is, you can call it Vy, and this is Vz. Now we have modified this circuit, therefore the nodes will be changed now. Previously we will be having these nodes here. This was node number 1, this was node number 0, ground is usually connected as 0, and this was node number 2. So there were only 3 nodes connected here, but after we have modified the circuit, our number of nodes has increased. Now this is node number 1, this point is node number 2, this point is node number 3, this point is node number 4, and this point is node number 5, and this is at the ground potential. We will call it a node 0. So now in the next stage we will be having a coding based on these node values. These node values actually define where our element is connected. Now let us assume that the value of R1 is equal to 1 kilo ohm, R2 is equal to 50 ohm, and R3 is equal to 10 ohm, and we also assume that our source voltage V1 is equal to 50 volts. Now when we will be using this thing to define this in the code, we have to start from the very first line. The very first line is a blank line. You cannot write a code on the very first line. So the first line is just the title, so we can say this is a test circuit here, and now we have to define, it's up to you, there is no sequence required to write the code. I mean, you can write this R3 at the very first line and you can define this V1 at the last line, but it does not matter. So in the sequence wise, let us first define all the voltage sources that are connected in this circuit. So V1 is connected between, this is assigned, we will be using a space here. So because we cannot just combine that thing, we will be writing V1 space first node space the second node, because this V1 is connected between node 1 and 0. Since 1 is connected with this positive terminal, so we are having this 1 first and then 0 second. And then we will be finding this space. Since this is a DC circuit, therefore we will be writing the type of the circuit here, where this DC is the, if we have an AC circuit, we have a separate code for defining the voltage sources. But since in this course we are only dealing with the DC sources, we are not concerned about the AC one. So this is simply a simple statement. We will be writing the value of the DC source here, which is the 50 volt. And then we will be writing the Vx here. Vx, remember, it's a dummy voltage source. Vx is equal to Vy is equal to Vz, all are having 0 volt. They are joined to measure the current of the branches which are a part of this circuit. Now Vx is connected between node 1 and 2. It's a DC source and a value of 0 volt. Similarly, we have the Vy, which is connected between node 3 and 4. It's a DC value and it has a value of 0 volt. And then we have Vz. Vz is connected between node 3, because this is the node 3, this is node 5. Since there is no element connected in this path, therefore we can consider Vz is connected between node 3 and 5, and it has a DC value of 0 volt. Now in the next stage, we are going to define the resistance values here. This is very simple. So we will be writing R1, which is the name of this resistance, and we are going to select, because it is connected between node 2 and 3. So this is 2, this is 3, and then simply we will be putting the value of this resistance, which is equal to 1000. And then we have this R2, which is connected between node 4 and node 0, because this is node 4, this is node 0, and it has a value of 50 ohm. Then we will be writing this R3, which is connected between node 5 and node 0, and it has a value of 10 ohm. And the last line of this code will be equal to dot end. So when we will be simulating this circuit, it will give us all the voltages at different nodes, and similarly we will be getting all the currents which are required for the branch of which are required for the R2 branch, R3 branch, and the source current. But one thing we have to write this in a specific format, which is known as .cir format. We will be renaming every file with this .cir format. So we will now see how we can put this circuit in a .cir format. So for this, I have opened this notepad file here. I will be writing the first line. As I have told you, it cannot be a part of the circuit. So I will be writing here, this is a test circuit, and then we have this V1 connected between node 1 and 0. It's a DC value of resistance of voltage 50 volt. Then we have Vx, which is connected between node 1 and node 2. It's also a DC dummy source. It has a value of 0. Then we have Vy. It is connected between node 3 and 4 with a DC value of 0. And similarly, we have this Vz 3, 5, DC 0. Then we will be defining R1 connected between node 2 and 3, having a value of 1000. We have R2 connected between 4 and 0, having a value of 50, and R3 connected between 5 and 0, having a value of 10, and then dot E and D. Now the most important thing here now is that I am going to click on this save as file, and here I have this all files. I will be selecting this all files, and I will write the name of this file. Now I will be writing this as test circuit .cir. Now if this will make this this will save this file as a .cir extension. So now I am going to save this file. That is saved. In order to simulate the circuit, now I will be using this PSPICE student version, which is available online. There is a PSPICE AD student. You just click on it and it will open here, and you have to open the file that we have saved. It is .cir file, and here it is. This is a test circuit.cir. We will open this file, and you will see that whatever we have saved on this notepad file is now appearing on this screen. Now in order to simulate this circuit, I am going to simulate this from this blue button. When I will simulate it, you can see here there is no error here, otherwise there are some red dots that will appear here. Red small boxes, bullets will appear here, so that will tell you that there is some problem. Again, you have seen here that there are 3 resistances and 4 voltage sources connected. These voltage sources contains those dummy voltage sources and the source and the source voltage that was connected in the circuit, as shown here with this V1. And then we can, after simulating it, there is a view simulation output file. When I will click on this file, this is a netlist that has been created, the test circuit, and there are different things that are available. So you can see here that at node 1, now if I just want to emphasize here, at node 1 we are getting 50 volt, because this is the let me change the color here. So you can see here this V1 has a value of 50 volt value, and this is between this node 0 and 1. So at this node 1 we are getting this 50 volt. Similarly at this node 2, since this is actually a dummy voltage source, Vx has a value of equal to 0. This means it's a shorted path. Therefore we have the 50 volt. Even at node 2 we have the 50 volt. Now at node 3, because this R1 is very large, it has a value of 1 kilo ohm. Therefore a considerable drop in the voltage can be seen here, and at node 3 we are only getting 0.4132 volt. And since these 2 branches are connected in parallel, therefore the voltage that is available at this node 3 will be the same for this R2 as well as for this R3. And similarly we have here at node 4 and node 5, because this Vx is equal to 0, Vy is equal to 0, and Vz is equal to 0, they are all short circuited paths. So whatever is available here, it will appear across this resistance R1, R2 and R3. So now we can say here is that the voltage is majorly dropping across this resistance R1. Now what we were interested was in knowing the value of this I2 and I3, and also this source voltage I1. So for this I1, if I just make it solid down here a little bit, you can see here that Vx is 4.959 e raised to the minus 2. So Vx is what? It is this value which is flowing. Vy is the current, and you can see here this Vy is greater than the value is less than the value of the Vz, because this Vy has a 50 ohm resistance connected and a 10 ohm resistance is connected here. So whatever the total current is, it divides equally into these 2 parts, as shown here. If you sum up these 2 values, 8.26 e raised to minus 3 and 4.1, you will get this 4.95 e raised to minus 2 ampere current.